Hey everyone, welcome. This is Mr. Abagina's first ever video. So sit back, relax, and let's get ready to take some notes on masses of atoms. So, in using masses, we can determine a few different things. So let's take a look at the first one is we can actually determine the mass of an atom or atoms, and we use the atomic mass. We use the atomic mass in AMUs to determine the mass of an atom or to indicate the mass of an atom. So for example, I can determine the mass of one atom of neon. So the mass of one neon atom, and that would be 20.2 AMUs, or atomic mass units. So the 20.2 comes straight from the atomic weight that you have on your periodic tables for each element. The second thing we could do is determine the mass of 1 mole of atoms. So this can be determined as the molar mass, okay? And the units for molar mass is grams. We can also call this the atomic mass in grams. So for example, if we wanted to find the mass of 1 mole of neon atoms, this would be equal to 20.2 grams. So just make a quick note of the difference in the units between the mass of a mole of atoms versus the mass of an atom. So it's grams versus AMUs. We'll summarize when to use these in a little table down below. Third is we can use molar masses as a unitary rate to find mass of one atom in grams, which is kind of handy. Even though an atom is really small, we can still determine its mass. So for example, if we wanted to do this and determine the mass of one atom of neon, we can use our friend Avogadro's number and the mole. So 1 mole of neon, there are 6.02 times 10 to the 23 atoms of neon. So I've converted atoms into moles. And now we can use our molar mass of 20.2 grams of neon in 1 mole of neon. Whoa, classic pen issues. To determine the mass of that one atom. So if our moles cancel out, we see we're left with grams of neon, and that ends up being equal to 3, here we go, 3, if I can ever write it, 3.36 times 10 to the negative 23 grams is the weight of one neon atom. So let's make sure we understand why this is in 3 sig figs. So we know that one atom is a defined value. There can't be any more than one atom in our example. So that is infinite sig figs. 1 mole, again, it's defined. It's infinite sig figs. 6.02 times 10 to the 23, that is 3 sig figs. And so is our molar mass, because those are both measured quantities. So those are 3 sig figs. So our final answer must be in 3 sig figs, so make sure we're always looking at significant figures. Okay, so let's kind of summarize when to use these units. So if we're talking about particles, so atoms or molecules, that's when we use the atomic mass. And the units, are AMUs, or atomic mass units. And for molecules, we call that the molecular mass, also measured in AMUs. Then if we're looking at moles of atoms or molecules, that's where we use our molar mass in grams. All right, so let's now take a look at the molar mass of compounds. So the molar mass of compounds is the sum of the molar masses of each element in the compound. So that sounds easy enough. Let's take a look at an example. So let's look at water. So we know that water has 2 moles of hydrogen in 1 molecule and 1 mole of oxygen in 1 molecule of water. So if we have 2 moles, each would be weighing 1 gram. And then to give us, 2 grams total coming from our hydrogen. And then we know that oxygen, its atomic weight is 16.0 grams per mole. So if we total those 2 numbers up, we get a total molar mass, the molar mass of the compound of 18.0 grams. All right. So let's give you one to try out. So go ahead and try chromium hydroxide. So what I would do is I would pause the video right now, go through it, and then come back and see the answer. All right, welcome back. Hopefully that try question went well for you. So let's take a look at the answer. So the mass coming from chromium is 52.0 grams, just the weight taken from your periodic table. We have 2 hydrogens because we know the 2 outside of the bracket applies to both the oxygen and the hydrogen. So 16 times 2, we get 32 grams coming from our oxygen. And then we have a total of 2 grams coming from hydrogen because that is 2 hydrogens, 1 gram each. So we add those all together and we end up with our final answer of 86.0 grams. So it's really, really important, and I made a little note here. I start it. Usually when we start things, here we go. Usually when we start things, they're important. So you need to make sure you're showing this much work when you're actually going through these on your own homework and on quizzes and tests. You don't want to lose silly marks for making simple math errors. So make sure you're showing as much work as possible. Okay, so just a quick reminder for diatomics. For diatomics, remember that's the at Hofbrinkel or the 7+1 rule. Those are the elements and which are found together. So we describe those as molecular mass because it's a molecule, or the molar mass. So if we look at an example like hydrogen, or H2, the molar mass for hydrogen is actually 1.0 grams times 2 because there's 2 hydrogens, so it's actually 2.0 grams if we have a hydrogen molecule. Okay, so we need to multiply the molar mass of the hydrogen by 2. So the same would go for nitrogen or chlorine or any of the other diatomic compounds. All right, so now we're ready. We've gone through how to calculate the molar mass of compounds. We can actually do a question. So let's look at our first example. It asks how many moles are in a 50.0 gram sample of glucose. And don't worry if you forget the molecular formula of glucose. It's right here, C6H12O6. So we're asked to calculate how many moles in a 50 gram sample. So the first thing you want to do in these types of questions is calculate the molar mass of the compound. So let's go ahead and do that. So we have 6 carbons, each with a molar mass of 12. So that gives us 72.0 grams coming from carbon. We have 12 hydrogens, each 1 gram, so it's 12 grams per mole. And then we have 6 oxygens, which is going to be 16 times 6 is 96.0 grams. I total all those up. I get 180.0 grams of glucose. And remember, this is the mass of 1 mole of glucose. So we can actually create a unitary rate from this. So let's do that. So we can create 2 unitary rates. So if we were looking for the amount of moles, then we could say it would be 1 mole of glucose divided by 180.0 grams of glucose. Or I can create a unitary rate to solve for grams. So it would be 180 grams of glucose in 1 mole of glucose. So because we're looking for the number of moles in this question, we would want to use the first unitary rate. So let's go ahead and do that. So if we have 50.0 grams of our glucose, we need to convert that into moles. So we'll use our unitary rate of 1 mole of glucose. There are 180 grams. And yes, you need to write out glucose each time. So our grams of glucose would cancel out. I'm left with moles of glucose, so that's good. That's what I want. So that's equal to 0.278 moles of glucose, C6H12O6. Okay. So now that we've gone through that example together, oh wait, let's talk about sig figs first. So again, it should be in 3 sig figs because our measured quantity at the very beginning, that's 3 sig figs. And then our 180 grams, that's 4 sig figs because that's a measured value. The rest, the 1 mole, is infinite. So our lowest number of significant figures is 3, so my answer must be in 3. Okay, so now that we've gone through this example, go ahead and try this next problem on your own. So pause the video here and then come back when you're ready to check over the answer. Have fun. All right, welcome back. So hopefully that try went well for you. Let's take a look. So if we're looking for how many grams of aluminum sulfate do you have in 2.56 moles? So the first thing you wanted to do was to determine the molar mass of the compound of the aluminum sulfate. So you should have gotten 342.3 grams. And then in using that, you could have created a unitary rate to then go through and multiply my 2.56 times 10 to the negative 4 moles of aluminum sulfate by my molar mass to give me my final answer of 8.76 times 10 to the negative 0.2 grams of aluminum sulfate. So if you feel like you were a little bit rushed in this video, feel free to go back, rewatch, and enjoy. Thank you for